Can you see the screen?
Yes, sir.
Okay. So we are discussing about consolidation and settlement due to consolidation. In that, we have understood two problems in the previous class. Today we'll take up another one problem. Okay, in the previous two problems, the first problem was little bit simple, that gave you the concept of how to find out settlement using consolidation. In the second problem, you have observed that while finding out the settlement using consolidation, you need to know the incremental stress whatever is happening because of the external loading occurring on the soil mass. And to find out that, you have also observed that for a point load, under a point load, if you want to find out the exact stress under the load because of that incremental stress under that load, you can use Boussinesq equation. And Boussinesq equation I have explained in the previous class. It's very simple to understand. It's just a, means theoretically if you try to understand it is difficult, but if you conceptually just understand the formula and how to use the Boussinesq equation, you have noticed that it's not very difficult to apply Boussinesq equation to find out the incremental stress. In the previous class also we have discussed about the trapezoidal distribution of stress, and how to find out the incremental stress using the trapezoidal distribution of the stresses. So just to recollect that, I will just show you the previous slide whatever we have discussed in the previous class. If you remember, this is what we have learned or seen in the previous class, that if a column is there on a footing and then there is a load coming onto the column, so through the footing the load will be getting transferred to the soil mass, and when the load is getting transferred to the soil mass, if you want to find out the incremental stress at a particular layer, and in case of consolidation of soil, you have understood now that at the middle of the clay layer is the position where you will have to find out the incremental stress. And 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 for doing that, you can just distribute the stress, or the dispersion line for the stress distribution will be something like the sloping line. And basically, if you take it in a three-dimensional view, that's what we have seen in the previous class also, that it will be something like this. So load, when it is coming over here, there will be trapezoidal distribution of load, and the the slope of this line through which this distribution will happen from the base of the footing, it will be always taken as one horizontal to two vertical. Okay, and if you consider this one horizontal to two vertical, then we have seen that the the length of um, the length and the breadth of the position, or the layer where you need to find out the incremental stress will be nothing but L plus Z and B plus Z, where Z is the depth from the base of the footing to the middle of the clay layer. Okay, so considering this concept, let us try to now understand how to find out settlement in a clay layer, clay layer through a numerical problem. Okay, so let us see. So see, this is a good problem where you can find out the this problem. Okay, I have already shared this thing with you, so let us try to understand this problem clearly. So see, in this problem, if you see the way in this book it is done, see, it is h is written as 2.1 meter, but we'll go with 2 meter only. Okay, so please correct it in your handout, that 2.1 meter will go with 2 meter only, because in the book The next part of the solution of the problem is mostly done using 200 centimeter or 2 meter. Okay, it's not taken as 2.1 meter. You can do it with 2.1 meter also, but if you go with 2.1 meter, I think these values will be little different, because you see here it is taken as 200. So there is some typographical mistake maybe, but we'll go with 2 meter only. Okay, so let's go to the problem and we'll try to understand step by step. So what is this problem says? You see, a 2-meter thick clay stratum is overlain by a 3.5-meter thick sand stratum, and now you have the understanding about overlain and underlain, right? So a 2.1 meter thick clay stratum is overlain by a 3.5 meter thick sand stratum. So that means on top of the overlain means, in the previous class I have explained you, overlain means the sand stratum is on top of the clay stratum and is underlain by rock. Which is underlain by rock? The 2-meter thick clay stratum is underlain by rock. So underlain by rock means just at the bottom of the clay layer there is a rocky layer, and top of the clay layer, overlain means that on top of the clay layer there is a 3.5 meter thick sand layer. The bulk unit weight, so bulk unit weight means gamma bulk is given over here. So bulk unit weight and saturated unit weight, so saturated unit weight means gamma sat is given, and they are respectively 6.9 kilonewton per meter cube, 6.9 kilonewton per meter cube, and 18.8 kilonewton per meter cube. Okay, while the saturated unit weight of clay is 20.1 kilonewton per meter cube. See very carefully, you should read this. So what it is being said, the bulk unit weight and saturated unit weight of sand. So the unit weight of sand, so the gamma sand, that means the bulk unit weight of gamma sand or gamma bulk sand is 16.9 kilonewton per meter cube, and gamma saturated sand is 18.8 kilonewton per meter cube. On the other hand, if you observe the unit weight of saturated unit weight of clay is, that means gamma saturated clay is 20.1 kilonewton per meter cube. And next you observe the groundwater table is at 0.75 meter below the ground level. This is another one very important point you should observe, because depending on the location of the groundwater table, while calculating the overburden pressure, you will have to find out which unit weight of soil will you use. That means whether you will be using saturated unit weight, bulk unit weight, or submerged unit weight. Okay, the liquid limit and void ratio of the clay are 53% and 0.96 respectively. So this void ratio, whatever is being said over here, you must understand now. This void ratio is the initial void ratio of the clay. That means this is the value of E naught, and liquid limit means WL value, WLL value is given, that is 53%. And why do you require WLL value? For finding out the consolidation settlement value, you need to find out the value of compression index, CC, right? So the compression value index, as we have observed in the previous class, and as you have seen from the Indian Standard Code also, that the value of the compression index in absence of the in absence of the laboratory test data, that means in absence of the E log P curve, you can directly calculate using the liquid limit of the soil, and the formula, I think it's given as 0. Cc is equal to 0. 0.009 multiplied by WL minus minus 10. Okay, so using that formula you can find out the compression index of soil. Now it is being told about the footing. So what is said, the square footing of 2.5 meter width. So the footing is here a square footing, so the length is 2.5 meter, the breadth is 2.5 meter. So you must understand, if it is a rectangular footing, then length will be different, breadth will be different, and as well the distribution length and distribution breadth will be different, but in this case distribution length and distribution breadth also will be same, because the footing is a square footing, and the footing is carrying a net vertical load intensity of 60 kilonewton per meter square. That means per meter square of the footing, the load is 60 kilonewton. So if you want to find out the total load on the footing, you must multiply the area of the footing with this load intensity. And the depth of the footing, it is said, it is 1.2 meter below the ground level. And for this footing, it is asked that you find out the probable consolidation settlement of the footing. Okay, so this is the problem is given, to you. Okay, now you need to find out the consolidation settlement, and we have seen that for finding out consolidation settlement, this is the formula in the previous class, and in previous many classes we are discussing it, and in the previous class also we have solved problem using this. Now for this problem, how do you find out the value of this SC? That is the point of question over here. So let us try to solve this problem step by step. It's a very good problem. Okay, and if you see the consolidation settlement problem, if you understand this problem and the previous problem, that is using Boguslav's whatever we have discussed, if you understand that, then settlement calculation is almost means you can say that any kind of problem comes in front of you, you should be able to calculate settlement. Okay, so let us try to understand this problem very well step by step. Okay, so let us go to the problem and then try to find out, understand it. Okay, now let us say, so this is what we have. Let me take this diagram. Maybe this diagram should help, or no, let me take fresh. Let us do it fresh, so that will be actually good. So you see, so what is said, it is said in the problem, it is said that first step by step you understand what is said. 3 meter thick sand stratum is overlain by a clay layer, is overlain by 3.5 meter thick sand stratum and is underlain by rock. So let's first draw the clay stratum. So solving this kind of problem, I always suggest you always draw the diagram first. If you can draw the diagram, then it will be very easy to solve the problem, because you will be able to visualize the problem very easily. Okay, so now you see, let us try to draw this. So let's say this is your ground level, can you see what I am drawing? Can you see? Hello.
Yes, sir.
Okay, so see, let's say this is your ground level. Okay, and at this, from this ground level, what is said, that there is a this layer. So this layer is basically a layer of sand, right? So this is a layer of sand. Let's say this is the depth of the sand layer, and the problem says this is, let's say, depth, this is the sand layer. So let me just write it over here. So I'll write over here. So let's say this is sand, and this sand layer, you see, this is sand layer, and this is the sand layer. And what is the depth of this layer? The depth of this sand layer is said in the problem, it is 3.5 meter thick, right? So the sand layer is 3.5 meter thick. So sand layer, it is 3 point, sorry, so it is sand, just a minute, so it is sand layer, and the layer thickness, or let us write it over here, 3.5 meter. That means 3.5 meter means this depth is actually 3.5 meter. Is it clear? So from here to here it is 3.5 meter. Okay. Now under this sand layer, there is a clay layer, because if you see the problem, it is said the 2 meter thick, I am not saying 2.1 meter, let us take it with 2 meter only, 2 meter thick clay stratum is overlain by 3.5 meter thick sand stratum. So under this sand layer, there is a clay layer. Okay, and the clay layer thickness, you see the thickness of this clay layer. So this is the layer of clay. So if I take it out here, this is actually your, sorry, control C, control. So this is your sand layer, and then this layer is your clay layer. Okay, and what is the thickness of this clay layer? Clay layer is basically 2.0 meter, let us write it here, 2.0 meter thick. And below this what is said, and below this we are not interested about any layer, because it is said the clay stratum is underlain by rock. Okay, so below this layer, basically what you have, below this layer you have some kind of rocky stratum. Okay, so if we write it rocky stratum, something like this, a fixed kind of boundary. So there is no sand, there is no clay below this. So basically this is a kind of rocky stratum. So that is what is being said in the problem, that is, this is actually your rock. So this is your rock. Is it okay? Now what is the problem saying? It is saying that the properties of the material are given. So property is given, bulk unit weight of and saturated unit weights are given, 16.9 and 18.8. So if you see the property wise for this sand, if you see, so property wise, if you see, then if I write the properties over here, then what is being said, that I am writing it gamma only here. Okay, or should I take a gamma from here, insert, then symbol, let me take a gamma from here, gamma, more symbols. Where is the gamma? Okay, So if I say this is gamma bulk, right? Gamma bulk is given. So gamma bulk, so if you take gamma bulk is given by how much? Gamma bulk is given as, what is the value of gamma bulk? Gamma bulk is given as 16.9. okay, so it is given as 16.9 kilonewton per meter cube, and for the, for this soil only, for this sand only, the gamma saturated, right? So the gamma sat, if I say this is gamma sat, so gamma saturated is given as, gamma saturated is given as 18.8. if you see 18.8 kilonewton per meter cube, so it is given as 18.8 kilonewton per meter cube. Is it okay? Everyone can see it? Let me make it little bit bigger. So can you see? So this is what is
Yes,
the
sir.
property, this is what is the property of the sand. Okay, now you see what the problem is saying. Problem is saying the saturated unit weight of clay. See, obviously the clay needs to be saturated. If the clay is not saturated, then consolidation will not happen. So clay, for clay, the bulk property is not required in this case at all, because only in a fully saturated clay the consolidation can happen. So in the problem it is given the unit weight of, saturated unit weight of clay is 20.1 kilonewton per meter cube. So the saturated unit weight, so if you see this saturated unit weight of clay, so I am putting it over here. So there is no bulk, you see, there is no bulk over here. So the saturated unit weight of clay, which is being defined in the problem as, or tested from the test result, it has come 20.1 kilonewton per meter cube. So it is nothing but 20.1 kilonewton per meter cube. So this is all about the stratum of the soil. Okay, so you see this clay layer, this is the clay layer, and this clay layer is fully saturated. Now the problem talks about, you see, water table. There is a presence of water table. So the groundwater table is at 0.75 meter below the ground level. So where is the groundwater table? Groundwater table, so let me draw another one line for the groundwater table, and let's say this is my groundwater table line. So let's say this is my groundwater table line. Okay, and this line, let me make it little bit dotted. Okay, so then it will be more clear. So line style, if I take it, let's say this one, if I take and then make it little bit bolder. So you see this is the location of the groundwater table. Okay, so groundwater table, as it is said, it is basically 7, how much, 0.75 meter, right? So groundwater table, so from here to here, if you take, so from here to here the depth is, from here to here the depth is how much? Bolo, the depth is
0.75.
0.75 meter. Is it clear? So now you see this is what is the problem talking about. Okay, so let me little bit make it this side, so it will not superimpose. Very challenging to explain all these things through online classes. So beautiful are those blackboards, right? But we are helpless. So let's try learn like this only. So this is 0.75 meter. Is it clear? Have you understood it? So
Yes, sir.
Yes, sir.
this is the problem. Now see, next step we are going. So see, the next step it is said, you see, we'll come to this void ratio and this part later. Let us draw the figure first. Okay, so a square footing of width 2.5 meter width. So square footing 2.5 meter width. Always remember, whenever you will be drawing the problem, whenever you will be drawing a foundation engineering problem, always in the front view draw the width of the footing. That means, suppose instead of in this problem it is given a square footing, but instead of this, if it is given as a rectangular footing of, let's say, length 3 meter by 2.5 meter, then 2.5 meter will be the width always, and you in the front view you always draw the width. Okay, so 2.5 meter width square footing carrying a net vertical load, I will come to this later, is to be founded at 1.2 meter below the ground level. So where is the location, where is the base of the footing? This is the base of the footing is within this sand layer only. You see, the base of the footing is within the sand layer only. It is not going inside the clay layer. So don't get confused. Let me draw the figure, then you will understand it more clearly. So let me take something. What should I take? Let me take a straight line over here. So say the footing. So there will be a column something like this. Okay. Control C, Control V. There is a column. Let's say something like this, and below this column there is a footing. Okay, so let me just little bit off, let me make it little bit upward, because 1.2 meter, so 0.75 meter, so 1.2 meter depth we'll have to make. So let's say this is the column, and let's say, let me take a rectangle and just draw a footing over here. So this is your footing on this side and this side. Let's draw it a little bigger. So at the centrally, the column is centrally placed. So have you got it? Footing, have you got it? So where is the location of the footing? So this is your column and this is the footing. And what is the depth of this footing? What is the depth of the footing? Please tell. So from the
1.2 meter.
From the ground level up to here, right? From the ground level up to here, absolutely, whosoever said 1.2 meter. So from the ground level up to this point, so this up to this is actually, so this is the diagram we have prepared. Okay, so this length is this depth is 1.2 meter. So this is actually the diagram. Okay, now you see, now let us come to the real consolidation problem. Okay, now you see the carrying a net vertical load intensity of 60 kilonewton per meter square. Okay, so net vertical load intensity of 60 kilonewton per meter square. That means what? That means you see this diagram, if you observe so on this footing, you see, this is a distributed kind of load. This is a small q. I have explained you, if you remember, using this formula, that capital Q into B into L, that is actually your total load. So what will be this load on this footing? What will be this load on this footing? So the load on this footing, it is going to be how much it is going to be? It is going to be, if you observe this problem, then you see the load intensity is given in kilonewton per meter square, right? So if you see the load intensity, that means we can say always here. So can I write here, or I'll have to write over here? So I'll have to write over here, I think. So you see the load intensity, small q, if you see, so small q will be given as, I'll change it, small q is given as 60 kilonewton per meter squared. right? This is your load intensity. So let us now write down the problem other definition. So small q is this much, and what are the other things given? You see the initial void ratio, it is given. So what is the initial void ratio given in the problem? Initial void ratio, let us go back to the problem again and see the initial void ratio is given as 0.96, isn't it? So the liquid limit and void ratio of clay, so the void ratio whatever is mentioned over here, it is the initial void ratio. The initial void ratio is given as 0.96. So let us write E naught value as equal to 0.96. okay, and what is the WL value or WLL value? WLL if we write, so liquid limit, how much is the liquid limit? Bolo,
Sir,
what is the value?
53%.
53%, absolutely correct. So it is 53%. So this is all about the problem. You see, nothing else is being told in this problem. See, और कुछ data है क्या इसमें? There is no other data is given in the problem. That's all. Okay. No, another one value is there. That is, it is square footing, right? So it is also said it is a square footing. So square footing, sorry, it is a square footing, and it is also said the width of the footing is equal to 2.5 meter. Now we have drawn everything, right? So we have drawn everything of the everything about the problem. What is happening to this? So let me okay. So you see so through this column load is coming to this footing, right? Through this column the loads will be coming to this footing. Just a minute, let us group it, otherwise now through this column the load is coming to this footing. And how much load is coming through this column to this footing? On this footing there is a load acting 60 kilonewton per meter square. That means if you see this diagram, this is what is coming, right? This is what is coming, 60 kilonewton per meter square load is coming, right? Small q. So if you take this small q value, then what will be the total load? So what will be the value of total load? Total load coming to the total load coming to the footing. So total load, if we define it as, if we tell it as q, capital Q, what will be the value? Small q multiplied by b multiplied by length. In this case it is a square footing, so it will be multiplied by b. So what will be the total load? You see, total load which will be coming onto this footing will be 60 kilonewton per meter square. So kilonewton per meter square multiplied by meter, 2.5 meter multiplied by 2.5 meter. So that is going to be kilonewton per meter square. Meter square and meter square will cancel out, and this will be total load acting on the footing. Okay. Now you see what is the formula we have learned. What is the formula we have learned for this finding out of this settlement? You see, the formula for finding out this settlement is this one, right? Formula for finding out this settlement, let me write this formula and then step by step we will understand this. So the formula for settlement calculation is this one. So now one by one I will ask you, and then you will have to answer. Okay. So let me first ask Vivek. Tell me, Vivek, what will be the value of this CC? Is Vivek there?
Yes, sir.
Bolo, bolo. Vivek, tell what will be the value of CC? Forgot? See, in the previous class we were discussing about the finding out the value of CC. Is it over here or not? No, it is not there. How do you find out CC? With help
Sir,
of what I can
sir,
find out CC?
0.09 into WL minus 10.
09 or 009?
009.
Yes, 0.009 into WL minus 10. So WL needs to be put in 53%, right? So basically WLL, so the formula for CC is 0.009 WLL minus 10, right? So what will be the value? So we can write 0.009 multiplied by WLL, in this case is 53, minus 10. So can anyone tell how much is the value we should get for CC?
0.387, sir.
0.387. So is it matching with the book, whatever they have solved? Let us see. So let us see the book. So 0.387, that's what we have done. So we are done with the first step. Okay, now come to the problem again. So CC value we have observed. What is the value of H? Tell me, what is the value of H?
Sir, 200 centimeter.
See, this is making problem because yes. So what is the value of H? We have told H is equal to 2 meter. Why H is equal to 2 meter? Because the depth of the H in this case is the depth of the clay layer. So a depth of the clay layer is H equal to 2 meter. You can take 200 centimeter. Absolutely correct. Whosoever has told. So now H is known. What is the value of E naught? E naught we know. E naught we already know from the problem. So the value of E naught is nothing but 0.96. So value of E naught is 0.96. Okay. So we know now CC, we know now H. I am just marking it with yellow. We know now E naught, right? Now what are the things not known till this in this problem? We don't know yet what is P1 dash. So what is the original overburden pressure? We don't know, and we are yet to know what is the value of this delta P dash, right? That means the incremental pressure on the layer of the clay. So now first step, if we find out this P1 dash, that means the original or the initial overburden pressure on the clay. So initial overburden pressure, if you want to find out, what you should do for finding out initial overburden pressure, basic soil mechanics understanding you will have to use that initial overburden pressure or initial effective overburden pressure you will have to find out using gamma multiplied by H, that means unit weight of soil multiplied by H. And for finding out effective overburden pressure, you must use the value of gamma according to the unit weight of soil. Some cases you may need to use saturated value, some cases you need to use bulk value, some cases you need to use submerged unit weight values. Okay, so let us try to find out what is the value of this P1 dash. So I will ask you, who can tell what will be the value of P1 dash? See, from this diagram now, once you have drawn this diagram, it's very simple to write what will be the P1 dash value. Okay, so what will be the value of P1 dash? Can anyone tell? What will be the value of P1 dash? बोलो, थोड़ा सा हिंट इधर में दिखा दिया, इसके बाद मैं पूछना चाहता हूँ. So where you will have to find out P1 dash? Can anyone tell?
At the middle of the clay stratum.
Absolutely correct. Very good. Okay. So at the middle of the clay stratum. Okay. So at the middle of the clay stratum we need to find out the overburden pressure. So at the middle of the clay stratum, let us draw this middle of the clay stratum. Okay, so this is actually your middle of the clay stratum. Okay, so this is your middle of the clay stratum. Let me change the line color, then it will be more perfectly understood. So this is your middle of the clay stratum, let's say. And what is this depth? Middle of the clay stratum, total clay stratum depth is 2 meter, right? So the middle of the clay stratum depth, so that way middle of the clay stratum depth from here to here if you take, so very important to understand from the diagram, because from the diagram problem will be becoming very simple, you see. So middle of the clay stratum, this is actually 1 meter, right? Now you tell me what will be the value of this P1 dash. So how do you find out? So at this level you need to find out what is this value of P1 dash or sigma naught dash, whatever you say, okay, or P naught dash, whatever you say. So what will be the value of this P1 dash? That means initial overburden pressure. How do you calculate? So you just go on multiplying with the gamma value with the depth of the soil. So see, for the initial part, now here you should be very carefully observing it. See, this is actually the water table. This dotted line shows the water table, right? So above the water table, which unit weight of soil you should use? This, and this soil is sandy soil, right? So above the water table, when you will be using, you must use the bulk unit weight of soil. And if you see in the problem also, it is being shown that. So above the water table, so if you observe here, the above the water table, the unit weight of soil is 16.9, or unit weight of sand is 16.9. okay, so what you are doing? Gamma bulk into H. So gamma bulk into H. In this case, gamma bulk is how much? 16.9 multiplied by, what should I multiply?
0.75.
Absolutely correct. 0.75 plus, what should I do? Plus after this, from this water table up to this layer we should go. That means up to the sand layer we should go. So what is this depth then? So the depth of the layer, that means 3.5 meter is the total depth, right? 3.5 meter is the total depth, out of which you have already calculated overburden for 0.75. So the left depth is 3.5 minus 0.75. This is the left depth. So from here to here I am telling you, right? So I am talking about the depth from here to here. So this depth is nothing but your 3.5 in minus 0.75. Now with this, what should be multiplied? What will be the unit weight of soil for this
18.8. So submerged unit weight.
Yes. So 18.8. Someone has told 18.8. See, 18.8 is basically the saturated unit weight of soil. But you see, the water table already has risen up to this level. So this portion of the soil will be under submerged condition, and I think that is being taken over here also. You see, 18.8, that is the saturated unit weight of soil minus gamma W they have done. So in this case, gamma W value as per the book only will be going. Instead of 9.81 kilonewton per meter cube, we are taking approximately 10 kilonewton per meter cube. Okay, so 18.8. so please understand this very carefully. Okay, so it will not be 18.8 multiplied by, it will not be 18.8, it will not be this, it will be 18.8 minus 9.81, or for approximate value we can write it 10 kilonewton per meter cube. What is this 10? This is nothing but your gamma W, that is gamma saturated minus gamma W. If you remember, we have already know, right? We already know what is your gamma What is your gamma submerged? If I write this here, so gamma submerged, oh baba, what happened? Gamma sub is what? Gamma submerged is equal to, let us make it little bit bigger, gamma sub is equal to gamma sat gamma sub is nothing but gamma sat, gamma saturated minus gamma W. So this is what we are doing. So you see, this portion of the soil, that means below this water table, this sand is under the submerged condition. So to find out the submerged unit weight, the saturated unit weight of sand is given. So from the saturated unit weight of soil, we are subtracting the unit weight of water, because in this case we are assuming the value of gamma. So what we are saying, the value of this gamma W, we are taking 10 kilonewton per meter cube. Approximately it is 10 kilonewton per meter cube, that means 9.81 kilonewton per meter cube, so nearly 9.81 kilonewton per meter cube. Okay, so this is one part. Now the next part, next, is it all or something else will come? See, we'll have to go up to this brown layer, right? Brown layer means this is the middle of the clay layer. So now still we are left with this much amount of depth, right? This much amount of depth we are left with. So this is actually, now you see, the property of the soil will change, and what will happen to this 1 meter depth clay layer? See, this total 2 meter depth clay layer is under saturated condition, because only if the clay layer is under fully saturated condition, then only what will happen? The consolidation will happen to the clay. So if we take this, if we take the middle of the clay layer, then depth of the clay layer is 1 meter, and 1 meter multiplied by how much? How much should I write here? Tell me.
20.1 minus
20.1 minus
10.
So 10 is your gamma W. Okay, so this is actually is the value of the initial overburden pressure. Okay, so basically this is your initial overburden pressure. I'll have to go on, keep on making it down like this, otherwise. Okay, so this is your value of initial overburden pressure. So you understand how to find out this P1 value? Is it clear? See,
Yes.
for any kind of problem, you'll have to go in this manner. So if you draw the diagram properly, see, this diagram is very important. You observe, if you draw the diagram properly, the problem can be solved in 2 minutes, nothing else. And I tell you, these kind of problems, the similar kind of problem, I will give you another one problem in a later date. See, engineering services exam, GATE examinations, in case of engineering services examinations also big questions come. Okay, so this kind of problems give you 15 to 20 marks flat, 15 to 20 marks. Only you need to have the conceptual understanding, otherwise you can solve the problem in 5 minutes, I tell you. But it's very important to have the conceptual understanding. If you do not have conceptual understanding, you will not be able to solve the problem. Okay, so this kind of understanding is very much required. So if you solve this equation, if you find out this value, you are going to get some value for this. And what is the value you will get? Can anyone calculate and tell, or should I write it from here?
Sir, 89.32.
89.32, that is what it is also given in the book. So it is given 89.325, how much? Kilonewton per meter square. Okay, clear? So So now again you go back to this formula. So you see what we are doing. See, 1 is known, basically 1 is also known because this is constant term. Now you see this P1 bar you have calculated, correct? So what is left in this problem now?
Delta P, sir.
Yes. So how to find out this delta P? That is the question now. So if we can find out the value of this delta P, then my problem is solved, right? So why this is not going down together, I don't know, because I'll have to do it again and again. So what will be the value of delta P? That is the question. So who can tell me what will be the value of delta P? How do I find out? Conceptually you tell me, then I'll explain. If you have the conception right, then it's very simple to do it. We have already explained the theoretical concept behind it. So what will be the value of delta P?
सर वो फॉर्मूला देंगे सर क्यू बी एल बाई एल प्लस जेड पी पर
Absolutely correct, you are saying. So we will have to calculate this delta P using this concept, this one, this trapezoidal distribution of load, right? So this trapezoidal distribution you see, and this trapezoidal distribution of the dispersion of the stress will always happen, as I have told you, you must remember, will always happen at a slope of, or at a slope of 1 horizontal to 2 vertical. And if it happens at a 1 horizontal to 2 vertical slope, in that case we have observed that if from the base of the footing, the place where you want to find out this delta sigma z, in this case in our problem we have written delta P. So if you want to find out delta P, that means we need to find out if we can find out the depth from here to here. If we can find out the depth from here to here, that means from the base of the footing till the middle of the clay layer, in this case, in our case, then we can easily find out this delta z. Can very easily find out the value of delta z. Okay, so this delta z value, this is wrong actually. Yes, previous class we have corrected it, I forgot to save it. Okay, so basically up to this depth you will have to calculate. So one of you have already told that it should be calculated using that formula. So basically you see the diagram will come something like this. You see, let me explain it again here. So see, there will be a trapezoidal distribution of load from here to here, and there will be another one line. So there will be trapezoidal distribution something like this from here to here. Okay, so and you see the slopes cannot be different. Okay, so what I have drawn, it's not very correct. It should be something like this. Okay, so this slope and this slope needs to be same. So let me draw it with a proper line, then it will be more clear. And let me change the color also. Color, let me change it to this one. So this is one. So the slope distribution of the stress is something like this, whatever we are seeing it now. So this is the slope distribution, right? So if you want to find out where you are finding out delta P, so where are you finding out delta P actually? So you see, you are finding out delta P. So you are finding out delta P somewhere here, right? So you are finding out delta P. Let me just insert a box, otherwise it will not be clear. So you are trying to find out delta P somewhere here, right? Delta P you are finding out at this middle of the clay layer. So middle of the clay layer, if you want to find out delta P, and in this case you see we are not using Bose-Einstein equation, we are not using Westergaard's equation. What we are doing? We are simply taking the trapezoidal load distribution as we have understood earlier, and this trapezoidal load distribution, whatever you see in the front side, that will also happen on the other sides also, right? So this load distribution, as in the previous class I have explained you, that this will be also happening at an area which will be having length equal to L plus Z and depth equal to L plus B plus Z, length equal to L plus Z and breadth equal to B plus Z. So our concentration point should be here. How to find out, and what is the Z? So let me point out the Z also, otherwise it will be. So see, the Z is, people get confused over here. So Z is nothing but this one, you see, Z is basically the depth of the, so this is actually your Z, you see, this is actually your Z. That means can you see this red line? So this is actually your Z. So Z means from the base of the footing to the middle layer of the clay, the depth of the soil will be taken as Z. And if this is being taken as Z, that means from this side if it is Z, then you see this is 1:2 distribution, this is 1:2 distribution. So what will be the value from here to here? This will be Z by 2. And on the other side also, if you go from here to here, this will be Z by 2. So the breadth of the footing, the breadth of the clay layer where the stress will be distributed will be B plus Z. And now you will have to tell me what is the value of this Z. So you need to tell me now.
3.3.
So let me write it over here Z. Okay. So let me write it over here Z. So what will be the value of Z? You tell me.
0.3, sir.
3.3. How are you getting 3.3?
So 3.5 minus 1.2 plus 1.
3.5 minus, absolutely correct. So see, that is why the diagram is important. If you don't draw the diagram, you will get confused. So from the diagram you see this depth, if you want to find out this depth, you see, very simple to find out. So from here to here, you know what is the depth? 3.5 meter. The depth of the footing is 1.2 meter. So that means from here to here, the depth is 3.5 meter minus 1.2 meter. So basically what he has said, that is 3.5 minus 1.2. Let me see, someone is trying to join. Should I admit this Surajit Kumar Jena?
Yes, sir.
He is in our class, na?
Yes, sir.
Yes. Because in today's first half class, structural analysis class, okay, again one student started disturbing. He was using slang languages today. You got? Means I admitted, and with some other mail ID he entered, and then started disturbing the class with very bad slang languages. It is must be from the class, okay. And I just after that, what we did, we have stopped that meeting, and then resend the meet link using calendar, okay. So using calendar event, see, in the calendar event only the mail IDs of the class, civil 2 classes there in one, and civil 1 class is there in one. So only to those the mail went, and immediately after getting the calendar, with the same name someone has entered, changed name, and again started playing the again tried to enter. That means you understand. That means when the new link is given, the new link is also being obtained by the student inside the class only, and he is only changing his name and disturbing the class. That is happening, and it is from civil 1, sorry, civil 2 class. So what I had to do, I had to stop the class after 15 minutes and then again restart. So it's very risky now to admit anyone. I am fearing to admit anyone when that is what is happening. The real problem, because of connectivity problem, if someone goes out and he tries to connect, rejoin, like just now Surajit Jena tried to enter, I was fearing that is he the correct one, because someone is coming with some with that name and using slangs in the class. It's so much disturbing. This is only happening in 5th semester, I tell you. It's a very bad precedence the 5th semester students are setting. I don't know. Means few of the students are making the name of the class, actually spoiling the name of the class. That is what it is happening. It didn't happen in 3rd semester class, even in the 7th semester class also never, no one has faced this. Only in 5th semester, few students, I think few students are trying to disturb it, and somehow we cannot catch them. That is the problem. Okay. So so that is what I was little bit fearing about it. Okay. So please I think multiple times I told you that you tell your friends that don't do this, that, but I think all of you have also told your friends also, but actually they should not be considered as friend at all. I think they are the misnomer for friends actually. So if you tell them, they will not understand, and they will spoil themselves as well as they will spoil you. So better from such type of people you just keep yourself away. That is what only you can do, and that is what only I can do also. So let me go back again. So z is equal to 3.5 minus 1.2. So you have understood this is 3.5 and the depth of the footing is 1.2. So we are getting actually this depth. So we are getting so we are getting what? We are actually getting this depth, and from here to here how much? From here to here, after that also I'll have to add this much, right? So I'll have to add plus 1. So how much it will come? Someone has told 3.5, 3.3, na? How much is the depth?
Yes, sir. 3.3.
3.3, sir.
3.3 or 3.4?
3.3 sir.
3.5 minus 1.2, how much it will come? 1.
सर 2.3 आएगा ना सर, प्लस करेंगे 1 सर 3.3 आ जाएगा.
2.3, yes. See, that is what 3.3 meter. Okay. So Z you know now. So if you know Z, you can calculate delta P. So you apply that. So what is Z? Z is nothing but your Q upon what? B plus Z, because that is what is trapezoidal distribution of load. B plus Z, L plus Z. In this case it is a square footing, so L will be equal to B, isn't it? L will be equal to B, right?
Yes, sir.
So can you calculate now delta P? So can you calculate delta P now? So let's write delta P over here. So tell me what will be the value of delta P. So delta P dash, let's write over here. Delta P dash will be how much? What is the value of Q? Q याद है Q क्या लिखा था? What is Q? Q is nothing but the intensity of load multiplied by B multiplied by B. So it is 60 into 2.5 into 2.5. Don't multiply, at the first hand please don't multiply, because that makes your problem little bit complex. At the end only you do multiplication and all other things. And this will be how much? What is b plus z? What is b? B is 2.5, right? Plus what is z? 3.3. 2.5 plus 3.3 multiplied by 2.5 plus 3.3. Is it clear?
See 11.14.
Delta p is coming 11.14.
Yes sir, 11.147. No, 15.
11.15.
Yes sir.
देखो कितना आ रहा है 11.147 एग्जैक्टली देखो मिला है बुक के साथ 11.147 absolutely correct. So 11.147 it is in kilonewton per meter square. Now see, now the problem is simple. Now you can easily find out. Now you can easily find out 62 Rituraj. Should I admit? Rituraj?
यस सर, अभी छोड़ दिया था ग्रुप,
ग्रुप छोड़ दिया था मतलब
मतलब लेफ्ट कर गया था
चले
सर,
गए
अभी नेटवर्क प्रॉब्लम होगा।
ठीक है ठीक कर दिया देखो अभी देखो now you see now everything is known in this problem. Which was left? Only delta p was left, right? So delta p value was left. So you see cc, you know cc you put back the value 0.387, h you put 200. So if I write at the top here, then I can write it this way. So what is the value of cc you have calculated? 0.387, right? And what is the value of h? So if we calculate the value in centimeter of settlement, then let us put value of this is 200. Okay, so 200 is the height, then 1 plus e naught. What is the value of e naught we have calculated?
0.96.
0.96, not calculated, it is given. Okay, so 0.96 it is given. Now what is the p1 plus p1 value we have calculated? P1 here we have calculated for the initial overburden pressure, it is 89.325, right? 89.325 we have. See, sorry, this is 89.325. so let me put back the value over here. So this is p1, so let us write over here, this is control v. So 89.325 will go over here, it will also come down because this is also. And what is delta p we have calculated? 14 point or 11 point something, what we have got? 11.147, right? So this is your 11.147. Control C, that control C, 11.147 ठीक जगह में बैठा है, गलत बैठा दिया। Is it okay? So if you calculate this, then you are going to get the value of settlement. Now let's see what the book says. See, 200. Okay, so 200 into 0.387, that's what we have done. You see, 200 into 0.387 divided by 1 plus 0.96 divided by 1 plus 96 log of 10. So you please remember this logarithmic base is log 10, okay, not e base. Please remember this, it is a base 10 log. So whenever you will be calculating in your calculator, always change your base to log 10 and then calculate. And then 89.325, let's see what the book is saying. 89.325 plus 11.147 divided by 89.325. okay, so if you calculate the value, you are going to get approximately 2.016 approximately value of settlement. So is it clear?
सर ये कैलकुलेटर में log 10 बेस कैसे लाएंगे?
ये तो मैं समझा नहीं सकता अभी।
क्योंकि सर फर्स्ट क्वेश्चन में सर
Yeah.
कैलकुलेट किए थे ना, तो वहाँ पे 9.0 आंसर आ रहा था, अब मेरा आंसर आ रहा था 8.87 आ रहा था सर।
नो, लॉग का बेस चेंज करने के लिए एक एक कैलकुलेटर में एक एक टाइप का होता है, ठीक है। यू जस्ट व्हाट आई विल सजेस्ट, you just give your calculator number, okay, in Google, that fx something and that, and then you just search for a YouTube video how to calculate log 10 and log e, okay, then only you will be able to understand. यहाँ से तो मैं नहीं दिखा पाऊँगा यहाँ पे, ठीक है। So it's simple to get it, okay. So log 10, I think e base and 10 base, that is two bases are given. I- I- different calculators have different mechanism to get it, okay. So you see, when you will be making your calculator on, at that time, on top of the top right hand corner or left hand corner, if it is written as ln, if it is written as ln means e base is e. If it is written as l or log, then it is log 10. ln means e base, okay. If it is written as log, then or l, then it is log 10. That way you may be able to understand, okay. So I think with this problem you have now the understanding of how to calculate settlement for saturated clay. If you have any doubt till this point, you can ask. Is there any doubt? Very slowly we have gone, and we have explained, I have tried to explain you every little step of this. So you see, this diagram is very important. See, if you can draw this diagram properly, then the problem can be solved in just 2 minutes, I tell you. So this is very important. Diagram, if you do mistake in drawing the diagram, and if you do mistake in reading and understanding the problem, then you will not be able to solve the problem. Otherwise, you see, the solution of the problem is very easy. So if you do not have any question, then should I move little forward? एक ही क्लास होगा, कल का क्लास, tomorrow's class will not be there, right? Utkarsh is there or not?
Yes, sir.
Utkarsh, have you class knows, na?
Yes, sir.
Everyone knows about it, right?
Yes, sir.
So see, I have some very critical work in college going on. So Monday classes are very a little bit difficult. Also, I think you were also telling that Monday's class is that. So I thought that only Sunday will take little bit longer period. Okay. So if you do not have any doubt on this part, then I can move for explaining another one part, because see, whatever till now we have understood, that is the settlement calculation for normally consolidated clay. Now I would like to explain you in this class only how to calculate the settlement for over consolidated clay, because see, it may not be very important from the perspective of your this immediate what should I say, university exam. You may be getting problems only for normally consolidated clay, but I have seen in GATE examinations as well as in engineering service examinations, some tricky problem comes where you need to understand the concept of settlement calculation for over consolidated clay also. So I would like to, I have one slide for that in the presentation. So I'd like to explain you. It's very simple to understand, but you should be very patient in hearing, and then you should think that why it is coming like that, and you will be very easily able to understand it. Okay. So let me explain today how to calculate the value of this SC, that means this SC. See, the formula for SC we have seen CCH divided by 1 plus E naught log of P naught bar or sigma naught bar or sigma naught dash, P naught dash, P1 dash, whatever it may be. That is basically the initial overburden pressure, and using incremental stress, delta P, somewhere you will see delta P naught, somewhere you will see delta P naught bar, somewhere you will see delta sigma naught bar, everything is same. So this formula holds good for normally consolidated clay, but if you want to find out for over consolidated clay, how will you calculate? Let us try to understand. Let me go to the slide. See, but before we go to understanding of the consolidation of, I just want to make you again remember this definition of over consolidated clay. This is very important, because from this only we will be getting into this, and this curve is also very important. So see, what was over consolidated clay we have explained. Over consolidated clay means the present overburden pressure. That means the presently the clay is in a state where the overburden pressure of the clay is less than the soil has experienced in past. That means in the past, let's say in the past, the soil was under a overburden pressure of 100 kilonewton per meter square. In the past, the soil was under the overburden pressure of 100 kilonewton per meter square. And I have given you one example also. Let's say at that time there was a hill on the soil, on top of the soil. Now the hill has been removed. So when the hill has been removed, let's say after removal of the hill, the overburden pressure will be getting reduced on the soil, and let's say at that time the overburden pressure on the soil is 80 kilonewton per meter square. That means 20 kilonewton per meter square reduction in the overburden pressure is happening just because of the removal of the what is called hill from the soil, on top of the soil. Okay, so at that stage what is happening? So when the hill is removed, so that is the present overburden pressure, but in the past the soil has experienced already a overburden pressure of 100 kilonewton per meter square. So the maximum effective past pressure, so the pre-consolidation pressure, as you understand now from this example whatever I am trying to give you, so the maximum effective past pressure, so what is the maximum effective past pressure the soil has experienced through? That is actually 100 kilonewton per meter square. So this 100 kilonewton per meter square stress which the soil had undergone in the past will be termed as pre-consolidation pressure. Now because of the removal of the hill, the soil will be coming to a state where the overburden pressure will be less than this pre-consolidation pressure, and this is actually being defined as over consolidation ratio. That means the soil was under a consolidation pressure, was under a pressure of 100 kilonewton per meter square, that is pre-consolidation pressure. Now after removal of the hill from the soil, let's say on top of the soil, it is reduced to 80 kilonewton per meter square. So the present effective vertical pressure on the soil will be how much? 80 kilonewton per meter square. So the over consolidation ratio thus will be 100 divided by 80. So that means it will be 10 divided by 80. Okay. So if you see this over consolidation ratio, that means if the soil, if there is any soil which is having over consolidation ratio, that is actually over consolidated soil. Now you see the type of change you will observe in a over consolidated soil for the E logarithmic P graph. So you see in case of in case of normally consolidated clay, if you observe, this graph was directly something coming down like this. That means the, if you see the normally consolidated clay graph, you see the graph was something like this. It is coming down like this, and then we have taken a tangent, and from that we should be able to calculate the value of Cc. But you observe here in this plot, you see this is a typical curve for a over consolidated clay. You see in this case what is happening, you see if you test a over consolidated clay soil sample in the laboratory, then you will observe the nature of the E log P curve something like this. That means you will observe that after from here to here, you see it is almost similar looking like, it is almost similarly looking like your normally consolidated clay. But a point will come, at a particular void ratio and at a particular effective pressure, you see, at a particular effective pressure. Okay, so what you are doing actually, you are increasing the effective pressure. So at a particular effective pressure, you see this curve will rebound back. You see it is going back something like this, it is going back something like this, and then it will again come back following this path. And you see almost this curve and this curve, if you match this curve and this curve, if you match, this is almost looking something like normally consolidated clay. But you see there is a loop coming in between, and this loop is coming because of the over consolidated clay. That means what is happening in this case, the stress in the clay, the past stress in the clay, rather we should say, it was much higher. Now because of the removal of something or because of some natural reason, the effective overburden stress has reduced, so there will be some swelling or the rebound of the clay. So this is actually defined with rebound index or swelling index. So when we will be talking about the consolidation of this is Amit Kumar 15.
Yes, sir.
So when we will be talking about this settlement calculation for this over consolidated clay, then we must understand this portion of the curve. Okay, and you understand why it is coming? It is coming because initially it was under some much stress, but that has been relaxed. Now if you want to pressurize it more, it will try to give a little bit rebound, and that rebound will be calculated using rebound index or swell index. And you see it's very simple actually. This one. Now you see this curve, this slide, you see. So how to calculate, let me make it full screen. So you see the calculation of settlement from 1D consolidation OC clay, okay, over consolidated clay. So how to calculate the over consolidation settlement, you try to understand from here. You see, very important to understand, you see there is another one term introduced. See, Cc we already understand. Cc is what? Cc is the compression index. So compression index, you see, compression index we know this is the slope of this curve. So this curve, you see, finally it is coming like this. So at the end, if you draw a tangent, you can easily calculate what is the value of Cc. But how do you calculate the value of this slope of the rebound curve of swell index? So this rebound index or the swell index, so it is also termed as Cs or Cr. You see, it is Cs or Cr. Every 2 minutes someone is. So you see, so this Cs or Cr, that means that means the slope of the rebound curve. And which is rebounding, I have explained you. So this curve is coming from here to here to here to here, and you see this is actually rebound, this is actually rebound, right? So if you take the slope of this curve, if you take the slope of this curve, you are going to get one index that is called CR or CS. Every 1 minute, of course, left. See, connections are disturbing, I think, for everyone, na? Okay, let me quickly finish it. So see, CS or CS or CR, it is the same thing, swell index or rebound index. Okay, now you try to understand these two equations very carefully. See, there are two conditions I have written. You follow this diagram. Everyone can see this diagram clearly, or should I make it little larger?
Yes, sir. Yes, sir.
Okay, so you see, in this diagram you observe one thing, see, there is a sigma naught. Can you observe? Let me make it little bigger. So see, there is a sigma naught dash. Can you observe this? So what is this sigma naught dash? So this sigma naught dash, you see the initial vertical effective stress. So that means this sigma naught dash is the pressure which is lesser than the over consolidation or pre-consolidation pressure. Please understand, this sigma naught dash is the original overburden pressure as now the soil is experiencing. And what is your over consolidation pressure? So the maximum past pressure, that is actually your over consolidation pressure, and that maximum past pressure, you see, that is sigma Vm. So it is somewhere here, you see, sigma Vm. So as you understand, for over consolidated clay, what will happen? This sigma naught will be lesser than this sigma Vm, because sigma Vm is your pre-consolidation pressure. And as you have understood that over consolidation ratio, when you have got over consolidation ratio value will be greater than 1, that means your pre-consolidation pressure or the maximum past pressure will be always greater than the present initial vertical effective stress in the soil. So sigma naught dash will be lesser than this sigma Vm dash. Is it okay? Now you see there may be two conditions. Now what is sigma naught dash? Sigma naught dash is nothing but the P1 dash as you have today we have understood, right? So P1 dash is what? P1 dash is initial vertical effective stress. Now on top of that, what is happening? On top of that, as you have understood in this today's problem, that some 60 kilonewton per meter square load is coming through the footing to the clay, and that is creating actually delta P. So this delta P, the amount of delta P may be such, this point is very important, the amount of delta P, in this case it is written here as delta sigma dash. So there may be a case that because of the incremental stress which is coming from the column to the footing to the soil, that incremental stress, if you add with this sigma naught dash, that means with initial vertical effective stress, the incremental stress if you add, there may be a case which may be lesser than this sigma Vm. That means this delta sigma may be falling somewhere here. There may be a case, मानो एक बड़ा सा पहाड़ था, वो पहाड़ को हटा दिया, तो पहाड़ को हटाने में बहुत स्ट्रेस कम हो गया सॉइल में, राइट? नाउ इसके बाद जस्ट अ मिनट, सो क्या बोल रहे हैं, एक बड़ा सा पहाड़ था, तो पहाड़ वाला स्ट्रेस क्या है? ये सिग्मा Vm डैश है, राइट? नाउ पहाड़ को हटा देने के बाद स्ट्रेस कितना हो गया? सिग्मा नॉट डैश हो गया. नाउ उस जगह में एक छोटा सा सिंगल स्टोरी बिल्डिंग बना रहा है, एक स्टोरी 2 स्टोरी का बिल्डिंग बना रहा है, तो क्या होगा? थोड़ा सा ज़्यादा स्ट्रेस इंक्रीज होगा. सो दैट इज एक्चुअली योर डेल्टा सिग्मा डैश. एंड दिस डेल्टा सिग्मा डैश, if you add with this sigma naught, it cannot exceed this value of delta sorry, sigma Vm, that means the maximum pass pressure. So there may be a condition something like that. So there may be a condition, sorry, there may be a condition something like that. So if sigma naught dash plus this delta sigma is less than equal to sigma c dash or sigma Vm dash. Sigma c dash or Vm dash means, that means the effective pass pressure whatever the soil has experienced, the effective pass pressure whatever the soil has experienced, if the present pressure after the increment also is lesser than that present pass pressure, then you see the index in the formula whatever for the settlement calculation you will be using for this SP, you see this is actually CR. Instead of CC you will be using it CR. This is the change you are observing. So CR is what? CR is nothing but your soil index. From where you will be getting it? You will be getting from the rebound curve slope. You will be getting it from the rebound curve slope. See, this CR value and CC value are different. So if the present effective overburden pressure after the addition of the incremental stress in the soil is more than is less than the past overburden past maximum pressure which the soil has experienced, then instead of this compression index, you should use the value of rebound index in the calculation of the settlement formula. And why is it? I have explained you. Now come to the second case. Now जो एग्जाम्पल पहले दिया वही एग्जाम्पल ले लीजिए. बड़ा सा पहाड़ था. सो पहाड़ जब था तब क्या था? Vm था, V डैश सिग्मा डैश Vm स्ट्रेस था. नाउ पहाड़ को हटा दिया. हटा देने के बाद स्ट्रेस रिड्यूस हो गया. रिड्यूस होके वो सिग्मा नॉट डैश हो गया. नाउ ये सिग्मा नॉट डैश के ऊपर अभी आपने एक बहुत बड़ा सा बिल्डिंग बनाया. लेट्स से 30 स्टोरी का बिल्डिंग बनाया, बहुत बड़ा बिल्डिंग. एंड वो 30 स्टोरी का बिल्डिंग जितना इंक्रीमेंटल स्ट्रेस क्रिएट करता है, दैट इंक्रीमेंटल स्ट्रेस if you add with the initial stress which is being there after the removal of the hill from the soil is more than that. So that means the condition is here, this sigma naught dash plus this delta sigma plus this delta sigma, this sigma naught dash plus this delta sigma is greater than this sigma Vm dash. So what is this sigma Vm dash? Sigma Vm dash is again, as I have explained, maximum past pressure. That means after the incremental stress is coming to the soil, when it is added to the initial vertical effective stress, if that amount of stress is more than the stress the soil ever has experienced in the past, then you see the settlement calculation formula will have two components. This is very important. This is very important because you see, in that case, before the settlement, before the what should I call, before the maximum past pressure it will reach, the formula of settlement calculation should be considering this compression index. And in that case you see the compression index value is compression index, value of the swell index or rebound index. So CR into H 1 plus E naught log. Here you see the change. See, in case of only when only rebound was happening, in that case you see sigma naught dash plus sigma dash, similar formula to the previous normally consolidated clay, only there is a change here where instead of CC you have used CR. But see the change over here. See the change over here. You see, here it is CR into H1 plus E naught log sigma Vm dash by sigma naught dash. You see, because you see till the sigma Vm point, you should be using the slope of the rebound curve for settlement calculation. Beyond this sigma Vm point, you should be using the compression index for calculation of settlement, and you must be adding these two parts for calculation of this settlement. So the formula will change: Cr into H1 plus E naught log sigma Vm dash by sigma naught. So sigma Vm is what? Maximum past pressure divided by the initial vertical stress, effective stress. Now here you see this part, this sigma Vm dash only we are using. We are not saying sigma naught dash plus sigma dash. Here you are not saying sigma naught dash plus sigma dash, because the soil will be experiencing more pressure than the soil has experienced in the past after the construction. So up to the point of the maximum past pressure, the formula will be using rebound index value. Beyond that, the formula will be using compression index value. So this Cc value will be using after that, and after that the formula is simple. Okay, so I think you should have now got the understanding of over consolidated clay, how to calculate the settlement for over consolidated clay also. Okay, it's not at all difficult. If you remember this graph is very important. This graph is very important, and you should conceptually understand it. So conceptual understanding is nothing but this: sigma Vm, that is the past overburden pressure, which is the maximum the soil has experienced. So after the past overburden pressure the soil has experienced, which is basically the pre-consolidation pressure. Okay, so in the question or in the typical type of explanation, you may be asked what is pre-consolidation pressure. In that, you see this sigma Vm is nothing but your pre-consolidation pressure. Now pre-consolidation pressure will be getting reduced because of the removal of something and that, and then the soil will be experiencing lesser stress than the pre-consolidation stress, right? So soil will be experiencing lesser stress than the pre-consolidation stress, which is actually sigma naught dash. And after that sigma naught dash, to that sigma naught dash, not after that, to that sigma naught dash, there will be adding up of incremental stress because of the external construction being happening on top of the soil, and that is given as delta sigma. Now there may be two cases. In one case, after the addition of the delta sigma to the initial pressure, that is delta sigma naught, so delta sigma naught plus delta sigma in some cases may be lesser than the past overburden pressure which the soil has experienced. Okay, that is sigma Vm, that means the pre-consolidation pressure. In some cases it may happen the after the incremental stress you add to the initial overburden pressure, that will be exceeding the value of past maximum pressure the soil has experienced, that is the pre-consolidation pressure. And in such case, in your settlement calculation formula, the rebound index as well as compression index both will come into the picture. And if you observe that rebound index will be when rebound index will be used, you see that the numerator of the formula is having sigma Vm dash, that is the pre-consolidation pressure, and you see the denominator in this case is having sigma naught dash. And for the compression index, the formula is exactly same as normally consolidated clay. So it is basically sum of normally consolidated clay settlement plus something which is being considered as rebound index or swell index settlement. Is it clear? So I think with this understanding we stop today. Now our understanding on settlement of consolidation is done. Now in the next class we will be trying to understand more theoretical part, or another one theoretical part of time rate of consolidation. Okay, so how with time, how much time it will be taken, for consolidation settlement. Okay, so this is what will be the next understanding we will be having in the class. Okay, so time rate of consolidation we will be understanding in the next class. It will be more mathematical understanding first, and then it will be again we will be solving problems and understanding the problems. So before we go to this time rate of consolidation understanding, you please try to go through during this week about the permeability, because permeability will come into picture while understanding this. Okay, so Darcy's law, permeability, all these things will come into picture, and the head, that is gamma W by H, that is the head of the pressure head, all these things. So there is a chapter in your soil mechanics book for permeability which you have already learned. So you please go through that permeability chapter once. So Darcy's law will come into picture. Okay, so in the next class we will be understanding that. So I think let us stop here and let me take the attendance.